welcome to Easy BTech channel. So in this module we will see what are signed numbers and unsigned numbers. So in general numbers can be either signed or unsigned. So an unsigned number which is nothing but which is having only the magnitude. It doesn't associate any sign bit. So an unsigned number will have only the magnitude, so no sign bit is allocated to it. So whereas a signed number will have both magnitude and also sign. So that can be positive or negative number. So numbers are of two types, signed numbers and unsigned numbers. Unsigned numbers doesn't have any sign bit, it will have only the magnitude part. So whereas signed number has both magnitude as well as also sign, so which can be positive or negative. So we will see one by one. So first we will look at what are unsigned numbers, then we will look at the signed numbers. So first we will look at unsigned binary numbers. So if you take an n-bit binary unsigned number, if you take an n-bit unsigned binary number, so it can have 2 power n distinct combinations. So that means 2 power n different combinations we can have if we take n bit. So in that the minimum number that we can represent is 0, whereas maximum number that we can represent is 2 power n minus 1, maximum number that we can represent with 2 power n minus 1. So for example, if you take n is equal to 3, so that is 3-bit binary number. So for 3-bit we can have total 2 power 3, so that means 8 different combinations we can have. And the minimum number that we can represent is 0 and maximum number that we can represent is 2 power 3 minus 1, so that means 7. So for example, if you take 2 bit, so total we can have 2 power 2, 4 possible combinations, so that means 0 0 0 1 1 0 1 1. So this is equivalent to minimum, this is the minimum number, corresponding decimal equivalent is 0. So this is the maximum number, corresponding decimal equivalent is 3. So this is about unsigned binary numbers. So similarly, what is the corresponding decimal value if I take an n-bit unsigned binary number? So if we take an n-bit unsigned binary number, what is the corresponding equivalent decimal value? So it is simple. So we have to assign the weights starting from the LSB 2 power 0, 2 power 1 and so on, 2 power n minus 2, 2 power n minus 2 and 2 power n minus 1. So we have to multiply the bit value with the respective weights. And then sum all those values. That means 2 power n minus 1 bn minus 1 plus 2 power n minus 2 bn minus 2 and plus and so on, plus 2 power 1 b1 plus 2 power 0 b0, 2 power 0 b0. So this we can write it as the summation n running from 0 to summation or I running from, we will take I running from 0 to n minus 1 bi 2 power I. So this is how we can find the decimal value of the corresponding unsigned binary number. For example, the given number for is 0 1 1 0 1. So this is the corresponding n bit, or this is a 5-bit, right? 5-bit unsigned binary number. The corresponding decimal value is 2 power 0, assigned bits 2 power 1 and then 2 power 2, 2 power 3, 2 power 4. So 0 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 2, right, plus 0 into 2 power 1 plus 1 into 2 power 0. So this will be 0 and this is 8 and this is 4 and this is 0 and this is 1. So this is equivalent to 13. So 01101 unbit 5-bit unsigned binary number, the corresponding decimal equivalent is 13 to the base 10. So this is about all the bits will contribute to the decimal value. All the bits will corresponds to magnitude. There is no this signed bit particularly in this unsigned binary number, right? So these, if these are the unsigned binary, the corresponding decimal equivalents are, we can know, this is 0, this is 1 and this is 2, this is 3, this is 4, this is 5 and this is 6 and this is 7. So this is the minimum number, minimum, and this is the maximum. This is the maximum for 3-bit. So this is 3-bit unsigned binary. 3-bit unsigned binary. So these are the corresponding decimal equivalent. These are the corresponding decimal equivalents. Right. So next we will see signed number representation. So whatever data we will see in our day-to-day life, all those are signed. So that's why signed number representation is important. So there are three possible approaches to represent this signed number. One is the signed magnitude representation. The other one is the ones complement representation. And the third one is the twos complement representation. So these are the three ways we can represent the sign number. One is the sign magnitude representation. The second one is the ones complement representation. And the third one is twos complement representation. Now we will look at one by one how to represent a sign number in these three possible approaches. So first one out of this, the first one is the signed magnitude representation. So in the signed magnitude representation, we'll have a particular bit is reserved. A one bit is reserved out of the n bits. Out of the n bits, one bit is reserved for the to represent the sign of the number. So here in the signed magnitude representation, MSB is reserved. MSB is reserved to indicate the sign of the number. So if MSB bit is 0, it indicates that number is positive. If MSB bit is 1, that indicates that number is negative. That number is negative. So out of the n bits, the MSB bit will indicate whether it is a positive number or negative number. The remaining n-1 bits that are there will represent the magnitude of the number. So out of the n bits, one bit is reserved to indicate the sign and the remaining n-1 bits are used to represent the magnitude of the number. So the range of numbers that we can represent in signed magnitude representation are minus 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So if you take a 4-bit binary number, in signed magnitude representation, we can represent minus of 2 power 4 minus 1 is 2 power 3 minus 1 2 plus 2 power 3 minus 1. So that means 8 minus 1 minus 7 2 plus 7. We can represent the numbers from minus 7 to plus 7. So this is about the signed magnitude representation, right? We will see the example. So positive numbers doesn't have, are the positive numbers for all the positive numbers, MSB bit is 0. If MSB bit is 0, it means it is a positive number. So plus 0 will represent 0, all zeros. Plus 1 will represent with 0, 0, 0, 1. Plus 2 will represent 0, 0, 1, 0. Plus 3 will represent 0, 0, 1, 1. plus 4 will represent with 0100, plus 5 will represent with 0101, plus 6 will represent with 0110, and plus 7 will represent with 0111. Now we will see how to represent the negative numbers. What we have said in signed magnitude representation, if the number is negative, we will represent the MSB bit as 1 and the remaining bits will indicate the magnitude. So here also only the MSB bit is 0. So that is why these numbers indicates positive numbers. So for negative numbers, the MSP is 1. The remaining bits represent the magnitude. So this is 0. So minus 0 will represent with 10000. Whereas minus 1 will represent 1001. So whereas minus 2 will represent, so simply the magnitude is same, but the sign bit is MSP bit is 1 here and the magnitude bits are same 0, 1, 0. Minus 3 means 1, 0, 1, 1. 4 means 1, 1, 0, 0. 5 means 1, 1, 0, 1. 6 means 1, 1, 1, 0. 7 means 1, 1, 1, 1. So the magnitude of any number you take, that is same, but for negative number we have the MSP as 1, whereas here we have MSP as 0. So the MSP bit will indicate the sign of the number in sign magnitude representation. So if this is 1, it indicates it is a negative number. If MSP bit is 0, it indicates it is a positive number. Right? Is it clear for everyone? Next we will see ones complement representation. But what is the drawback here? So the major drawback of this signed magnitude representation is two different representations for positive 0 and minus 0. So this is the drawback. Why? Because why this is drawback? Because in general we don't have any plus 0 and minus 0. 0 doesn't, plus 0 will not have different value and minus 0 will not have different value. So both will have the same value. But in signed magnitude representation, we have two different representation for plus 0 as well as minus 0. So that is the drawback of the signed magnitude representation. Two different representation for 0 is the drawback of the signed magnitude representation. Now we will see complements of the number. So these complements of the number is used to represent the signed numbers, right? So we'll see one by one. So complements, what are complements and what are is its use? So complements are used in digital systems to simplify the subtraction operation. So this is one of the application of the complements of a number. So it simplifies the subtraction operation, and also for logical manipulation we will use the complements of the number. Also it is used for logical manipulation. So there are two types of complements. Any base or radix number you take, any base or radix number you take, we will have two types of complement. One is the radix complement, or it is also known as R's complement. The other one, the second complement, is diminished radix complement or R minus 1's complement. So these are any radix you take, always will have two types of complements, radix complement and diminished radix complement, or R's complement and R minus 1's complement, right? So always for any number system we will have two types of complement. So for example, if you take the decimal number system, so we will have tens complement and nines complement, because we have R's complement and R minus 1's complement. So 10 minus 1 is 9's complement. So for decimal number system we have two types of complement, 10's complement and 9's complement, right? So similarly for binary number system, we have two types of complement. Those are 2's complement and 1's complement. 2's complement belongs to r's complement, and 1's complement belongs to r minus 1's complement, r minus 1's complement. So any number system you take will have two types of complements, r's complement and r minus 1's complement. So first we will see for binary number system the 2's complement and 1's complement. So in 1's complement representation, what is the basic idea means positive numbers are represented exactly as in signed magnitude form. So this is the basic idea. Positive number are represented exactly as in signed magnitude form. Only the negative numbers are represented in 1's complement form. So the positive numbers doesn't change. So how we represent it in signed magnitude form? So we'll represent in the same way, but negative numbers are represented in 1's complement form. In 1's complement form. Right? Now we'll see how to compute or how to find the 1's complement of a given binary number. How to find the 1's complement of a given binary number. So to find the 1's complement of a given binary number, what we have to do means we have to change 1 to 0 and zeros to 1. To find the 1's complement of a number, what we have to do means the given binary number we have to change 1 to 0 and 0 to 1. So that's it. It is very simple. 1's complement is very simple. So here also the MSB bit will indicate the sign of the number. Sign of the number. The most significant bit will indicate the sign of the number. So if it is 0, MSB bit is 0, you can say that it is a positive number. You can say it is a positive number. If MSB bit is 1, here also you can say like in signed magnitude form, it is a negative number. So positive number will have 0 in MSB position, whereas negative number will have 1 in the MSB position. Right? We'll see how to represent the binary numbers in 1's complement form. Signed magnitude, signed numbers in 1's complement form. So for example, if you take n is equal to 4, n is equal to 4, as I have said, positive numbers will represent the same as in the case of signed magnitude representation. So the MSB bit is 0, the remaining bits will indicate the magnitude. So if MSB is 0 means you can make sure that it is a positive number. And how to represent the negative numbers in 1's signed 1's complement form? We have to find the 1's complement of the corresponding positive number that indicates signed 1's complement representation. So how to find 1's complement? To find the 1's complement of a given number, we have to change 1's to 0 and zeros to 1. So this is the simple operation. So here we have all zeros. So minus 0 will be represented simply with all ones. So next minus 1. So take 1's complement of this. So it is 1 1 1 0 1 1 0. So minus 2 representation is 1 1 0 1. Right? So minus 3 it is 1. So simply we are taking 1's complement. 1's complement means changing zeros to 1, and 1's to zeros. Minus 4 it is 1 1 0 1 1. Next minus 5 it is 1 0 1 0. Minus 6 it is 1 0 0 1. Minus 7 it is 1 triple 0. So you see, so positive numbers MSB bit is 1, whereas negative numbers MSB bit is 1. So if, and the second difference is all the positive numbers are will have the same representation like in signed magnitude, only the negative numbers we have represented in ones complement form. For all the negative numbers we have MSB bit as 1. So if MSB bit is 1, whether it is signed magnitude or signed ones complement or ones complement representation, it indicates it is a negative number, right? So the range of numbers, as you can see, so here we have considered 4 bit. So for 4 bit, the maximum number positive number is plus 7 and maximum negative number that we have represented is minus 7, minus 7. So the range of numbers that we can represent with one's complement is the maximum number is plus 2 power n minus 1. So if you take the 4 bit, the maximum positive number that we can represent is 7 and the maximum or the minimum negative number that we can represent is minus 7. Minus 7. So here also the drawback of one's complement is, so you can observe two different representation for 0 like in signed magnitude form. So here also we have two different representation for 0. So you can observe here, you can observe in the table, plus 0 we have represented with all zeros, whereas minus 0 we have represented with all ones. So this is the drawback of ones complement, two different representation for zeros, two different representation for 0. But what is the advantage of ones complement representation is, ones complement representation is subtraction operation also we can done with the help of ones complement, like addition operation, or the subtraction operation we can convert it into addition operation. So that is the advantage, one of the advantage of ones complement representation. So thereby it leads to substantial saving in circuitry. So we don't require two circuits for subtraction and addition. So by using adder circuit, we can do the subtraction operation also. That is the advantage of ones complement representation, right? Now we will see the twos complement representation. So here also the important thing is positive numbers are represented exactly as in signed magnitude form. So there is no difference, whatever may be the representation that we will use, all positive numbers are represented in the same way. So all will have the same representation. Only the negative numbers are represented differently, or they will have different representation in signed magnitude, ones complement and twos complement. All will not have the same representation coming to negative numbers, but positive numbers have the same representation in all the three representations. So that is the important point that we should remember. So negative numbers, how we will represent negative numbers? Negative numbers we will represent in twos complement form. Negative numbers we will represent in twos complement form. So the next question is how to find the twos complement of a given number, so that we will see now. So how to compute the twos complement of a given number? So what we have to do means, so we have to first we have to convert ones to zeros and zeros to 1. So we have to complement every bit. So changing the number from 1 to 0 and 0 to 1 is known as complement. Is known as complement. So it is changing 1 to 0 and zeros to 1. It is same as one's complement. Then what is the additional thing that we have to do means, we have to add 1 to the resulting number. So that means finding the twos complement we can say as, or we can say as, we have to find the ones complement of the given number and then we have to add 1 to that number, we will get the twos complement of the number, right? So here also the MSB bit will indicate the sign of the number. MSB bit will indicate the sign of the number. So if it is 0, it indicates it is a positive number. If it is 1, it indicates negative number. So this is the another important point in all the three representation. So positive, if the MSP bit is 0, it indicates it is a positive number. If MSP bit is 1, it indicates it is a negative number. So this is the important point everyone should remember. So if the MSP bit is 1, if you observe in the signed representation, if MSP bit is 1, it indicates it is a negative number. If MSP bit is 0, it indicates it is a positive number. Right? So we'll see the representation for 2's complement representation for n is equal to 4. So as positive numbers will have the same representation in all the three representations, signed magnitude, 1's complement and 2's complement. So the only difference is representation of the negative numbers So we will see first for 1. So plus 1 is represented in this way. So minus 1. So first we have to find the 1's complement. So if you find the 1's complement, it is triple 1 0, and then we have to add 1 to find the 2's complement. So the corresponding minus 1 representation in 2's complement representation is all ones. So for minus 2, first we will find the 1's complement. It is 1 1 0 1, and then add 1. So if we add 1 plus 1, sum will be 0, carry will be 1, and the remaining is 1 1 0. So minus 2 will be represented 1 1 1 0 1 1 0. So next minus 3, I will write here by finding the 1's complement, and then I will add 1. I will straight away write the 2's complement. You can cross check in this way also. So it is equivalent to 1 1 1 0, and it is 1 1 0 0, whereas this one minus 5 how will represent means 1 0 1 1. Minus 6 is 1 0 1 0. Minus 7 is 1 0 0 1. So whereas minus 8 will represent here with 1 triple 0 1 triple 0. You can cross check. So these are all the representation for these negative numbers. So here the difference is we don't have two representation for 0. We don't have two representation for 0. Instead of that, we have the representation for minus 8, which is 1 triple 0 1 triple 0. So how to find here the corresponding decimal value is, if the number is in 2's complement representation, how to find the corresponding decimal equivalent is, for the MSP bit we have to assign negative value, that is negative weight. So for example, if you take 1 triple 0, so assign minus 2 power 3, for the remaining bits it is same. So this is equivalent to minus 8. So for this, if you take all ones case, so for the MSP you assign minus, so minus 2 power 3, so this is 2 power 2, this is 2 power 1, and this is 2 power 0. So minus 8, so this is 4, and this is 2, and this is 1. So this will give minus 1. So similarly you can find for the others also. So to find the corresponding decimal equivalent, for the MSP you assign the negative weights, for the remaining you assign like normal, you assign positive weights, and then add, multiply the respective bit with the respective weight, and then add all those, you will get the corresponding decimal equivalent. So the advantage of the 2's complement representation is we don't have two representation for 0. So that is why 2's complement representation will be used in almost all digital systems, because signed magnitude representation and 1's complement representation have two representation for 0. So this is not the case of 2's complement. So that is why we will use 2's complement representation. Right? So the other difference with compared to the other two, so the maximum positive number, if you take the 4 bit, you can see it is 7, and whereas the minimum number that we can represent is minus 2 power n minus 1, that is minus 8. You can cross check. You see the maximum positive number that we have represented is plus 7, and the minimum negative number or the negative number that we have represented is minus 8, right? So the advantage is of 2's complement is, so unique representation of 0, unique representation of 0. So that is the advantage of 2's complement representation. So that is why almost all digital systems use 2's complement representation. 2's complement representation for storing negative numbers. For storing negative numbers, we will use 2's complement representation. Is it clear for everyone? So we'll see just comparison. So if you take a 4-bit number, 4-bit number. So for example, if you want to represent 7, plus 7 and minus 7. So in signed magnitude representation, we will see how we will represent. 1's complement representation we will see, and 2's complement representation we will see. So plus 7 will be same in all the three representation, whether it is signed magnitude form or 1's complement form or 2's complement form, whereas difference is only in representing minus or negative number. So in signed magnitude form, minus 7 will be represented with the MSB bit as 1, MSB bit as 1, whereas in 1's complement we'll simply take the 1's complement of plus 7. If you take 1's complement of this plus 7, it is 1 triple 0, whereas to get the corresponding representation of minus 7 in 2's complement, we have to add 1 to the 1's complement of the number. So that is 1 0 0 1. You see, so minus 7 is represented differently in sign magnitude representation, 1's complement representation and 2's complement representation, but for plus 7 representation is same in all the three representation. So in this class we have seen what are the different types of numbers. We can have signed numbers and unsigned numbers. In unsigned numbers, all the bits will represent the magnitude, but here in case of signed numbers, we have three different representation. One is signed magnitude, the other one is 1's complement, the other one is 2's complement, and plus 7 are the positive numbers are represented same in all the three systems. The only difference is minus 7 or the negative numbers are represented differently in different systems. So the other thing is, if the MSB is 0, if the MSB bit is 0, it indicates it is a positive number. It is a positive number. If MSB bit is 1, you take all the three systems. If MSB is 1, it indicates it is a negative number. It is a negative number, right? So this is, I will end here. So in the next module, we will see the subtraction operation by using 1's complement and 2's complement. So thank you for watching. So I request everyone to subscribe the Easy BTech channel and share to your friends. Thank you.